Hello, Professor. We are Group 10. Today, my team members and I will present a case study on science communication based on no-code big data analysis with the same global climate change analysis. In this presentation, we use the global surface temperature dataset provided by the Kaggle platform, combined with big data visualization to explore the long-term trends of climate change. First, regarding the data source for this analysis, we select the climate change Earth surface temperature dataset from Kaggle, which contains global surface average temperature records spanning from 1750 to recent decades. This data is recorded monthly, including dates, temperatures, and their uncertainties. Through this long-term and systematic data accumulation, we can observe and analyze the overall trends of climate change. This dataset is not only scientific and systematic, but also highly suitable for supporting science communication. It helps to transform the abstract concept of climate change into an intuitive and perceptible temperature curve, making it easier for the public to understand the complex issue of global warming. Additionally, this dataset is well-structured, containing both global and regional data, making it ideal for multi-dimensional analysis. In this following presentation, we will use this data to plot global surface temperature trends, revealing the full picture of temperature changes over the past 2 centuries. This not only provides a scientific basis for research, but also offers strong visual support for public education, policy making, and media reporting. This above is an introduction to the theme and data source of this analysis. Next, my team members will further explore the trends of climate change and its application value in science communication through data visualization.
Next, I'd like to get you through this global land temperature trend chart. On the horizontal axis, we see the timeline from 1750 to the present. On the vertical axis, we see how the temperature has changed over time. There are 3 clear stages in this trend. From 1750 to 1900, the temperature line stays fairly flat, like a clam, steady heartbeat. This shows the climate was stable before the industrial era. But starting in the mid-1900s, the line begins to rise slowly but steadily, like a hiker walking uphill. Then comes the 21st century and the line shows up almost vertically, like going straight up a cliff. This sharp rise is the most dramatic and alarming part of the entire chart. This silent line tells a loud truth. Our planet is running a fever, a warming sign that can't be ignored. Now let's look at the 4 key takeaways from this chart. First, although there were some ups and downs between 1750 and 1900, the overall trend since the mid-20th century is clear. Temperatures are rising steadily and faster than ever. Second, since 2000, we have seen constantly higher temperatures than at any time in the past 250 years, often about 9.5 degrees centigrade. This is strong evidence that human activity is driving modern climate change. Third, compared to the pre-industrial era, the Earth's average land temperature has gone up by about 1.5 degrees centigrade, which is well beyond natural warming. Finally, this kind of long-term trend chart is very useful in science communication. It helps people understand the difference between climate and weather, and reminds us why urgent climate action is so important.
Now let's explore why this climate data matters, who benefits from it, and how it can be applied. Why does this data matter? This dataset offers a long-term, scientifically validated view of global temperature trends. It helps us distinguish between short-term weather and long-term climate change. With over 200 years of data, it provides strong evidence of human impact on the planet. It also includes uncertainty ranges, making the conclusion more robust and transparent. Who benefits from it? Scientists use it for climate modeling and validating zeros. Policymakers rely on it to design and monitor climate policies, such as the Paris Agreement. Journalists and science communicators use it to tell accurate, data-driven climate stories. Educators bring real-world data into classrooms. The public gains access to open, trustworthy climate information. How can the findings be applied in policy development to track progress towards the 1.5 target? In local adaptation by using regional data to build climate strategies, in science outreach to create visual tools that explain climate urgency, in predictive modeling to forecast future climate scenarios, and in public engagement through citizen science and open platforms. From the data, we see several important insights. First, global warming is accelerating. Between 2015 and 2025, 9 of the 10 warmest years on record occurred. Second, land areas are warming faster than oceans. For example, from January to April 2025, land temperature rose by 2.36 compared to pre-industrial levels. Third, the data is scientifically validated and aligns with funding from NASA and other major institutions. Looking forward, we can use this data for real impact. We can monitor climate change in real time, combine it with social and economic data, and communicate it effectively to different audiences. This is how to turn data into actions. In short, this data empowers action from classrooms to governments and helps us all make informed decisions for a sustainable future. That's all. Thank you for your time and attention.